All right, let's move on to another shape. In these notes, we'll be looking at pyramids and cones, specifically square pyramids and cones. And we're going to look at volume and surface area of those shapes. So, a pyramid is a 3D shape with triangular sides. So if you look at these pictures, the square pyramid has a square base and 4 triangular sides that come up to a point. And because it is a square pyramid, all 4 of these triangles are the same. Now, a cone is a little different. It has a circular base and a single curved surface that goes up to a point, but it's easy enough to include when talking about square pyramids, so we will include that in these notes as well. So the volume of a pyramid, if you think back to a volume of a prism, it was area of the base times the height. And pyramids are similar, except the volume is 1/3 of that. So it's 1/3 times the area of the base times the height. So that's a good formula to use. And again, B is the area of the base shape. So it would be the area of the base square times the height of the pyramid, the distance from the bottom to the top, and then the 1/3 is just divided by 3. Surface area works the same as a prism, just add the areas of all the sides. So for this square pyramid, we would have 1 square and 4 triangles to add together. Now for a cone, it's pretty similar. The volume actually is the exact same. It's 1/3 times the area of the base times the height. Now because it is a circle for the base, a lot of times you'll see that specific formula, 1/3 times pi r squared times the height. But pi r squared here, again, is just the area of the base. So you can think of these as having the same formula, except swap out the area of the square for the area of the circle. Now surface area is a little different because we have one flat side here, but then this curved surface on top. And so the surface area of a cone is the area of the circle, that's pi r squared, plus the area of the curved shape on top of the circle is pi r L, where L is the slant height, the distance from the top all the way down the side to the bottom. So for a cone, we have a few important measurements. The height is the distance from the bottom to the top. The radius is the radius of the bottom circle, and L is the slant height there. It's called the slant height. So let's try a couple of these and we'll see how it goes. So we're going to find the volume and surface area of one of each. So for this square pyramid, you can see we have a square with sides of 20 meters on the bottom. The height of the pyramid is 13. And we also we are given the slant height here of this square pyramid. And importantly, it's not the corner distance, that would be longer, but it is the height of this triangle on the side. And we'll need that for surface area. So let's first find the volume. In other words, area of the base times the height. So the area of the base is a square, 20 times 20, times the height of the pyramid, which is 13. I forgot my 1/3. So times 13, all divided by 3, right, times 1/3. So for the volume, we'll do 20 times 20 times 13. This would be the volume of a square prism with the same base and height, but then we divide it by 3 to get our overall volume here, which is 1,733.3 meters. Now, surface area, we have 5 sides to add up, 4 triangles and 1 square. the square is pretty straightforward, right? It's 20 by 20. So the area of the square equals 20 times 20, which is 400. Now we have 4 identical triangles, so we can just find that once. And area of a triangle is 1/2 base times height, and the base of the triangle is 20, and the height is 16.4. So 16.4 times 20 divided by 2 is 164. We do have 4 of those triangles. So multiply that by 4 is 656, plus the 400 for the square, and we get a surface area of 1,056 meters. If you were to draw a net for this shape, you'd have your base square in the middle, and then your 4 triangles like that. Let's try the cone. The cone is a little more straightforward, I think. So the square pyramid, pretty simple, but you do have to remember to add up all 5 sides. And the cone, we're just going to use a formula. So the volume is, again, 1/3 area of the base times height, same as the pyramid. So that's the area of the base is the circle with a radius of 6. So that's pi times 6 squared times the height of the cone, which is 8. So times 8, all divided by 3 for the 1/3. So the volume here, 3.14 times 6 squared, which is 36, times 8, all divided by 3, which is 301.44 meters cubed. I think I might have forgot the cubed over here and the squared right here. Meters cubed. Okay, there's the volume. Now the surface area. Again, we're just going to use the formula. So it's the area of the circle, which again is pi times 6 squared. And we're going to add to that the area of the curved surface, which is pi times radius times L, the slant height, which is 10. So 6 squared times pi is 113.04. We're going to add to that pi times 6 times 10, which is 188.4, for a total of 301.44 meters squared. Now, in this case, they ended up being exactly the same, which doesn't usually happen, but it did in this case. That is interesting. All right, well, there you have it. The surface area and volume of a square pyramid and a cone.